Hello everyone, welcome back to the solutions for the 6th term examination problems. Again, we are looking at a past year question. Here we have a simultaneous quadratic equation. Alright, so we have done simultaneous equations and we have done quadratic equations, but this one is a mixture of both of them. So how do we handle this? Now, to handle this, we would actually go for the comparison of coefficients. Alright, so you can see that these two equations are actually the same, right? The first one that we have been asked to analyze is the same in the set of equations that we have been asked to solve. Alright, now this is identifiable because we have this term as well as this term here. Now I have solved this equation that is why I know that these are same, but right now you can only assume that they will be same. Alright, we have to first determine the coefficients a, b, c and d. Once you determine them, we will see that these two equations are same. Alright, and then we will follow the same procedure for the other equation. Okay, let's go. There are a lot of calculations, so just make sure that you don't make any mistakes. Alright, because if you make a mistake in one of them, there are 4 variables, the mistake will start to compound and then we'll end up with a completely wrong solution. So let us name this one equation a. So for a, we will look into the RHS. This gives a into x minus y plus 2 whole square plus b into cx plus y whole square plus d. A lot of algebraic calculations here. So this will be a into x square plus y square plus 4 minus 2xy minus 2y plus 2x, right? And that would give you b into cx square plus 2cxy plus y square plus d. Luckily most of the signs here are positive, so not a lot of negative coefficients to take care of. Anyway, the coefficient of x square will be a and bc, right? So a plus bc x square. Similarly, the coefficient of y square will be a and b plus a plus b y square. The coefficient of xy will be 2bc minus 2a, right? Plus 2bc minus 2a xy. The coefficient of y is minus 2a, that's it, minus 2ay. And then the coefficient of x is plus 2a plus 2ax, and then we have 4a plus d, right? This is the simplified form. Now once we compare it with the left hand side, okay, instead of comparing with LHS, I'll write comparing coefficients. That will be more accurate. So comparing coefficients with LHS, what would we have? We would have a set of equations, right? We would have a plus, oh, this will be c square, right? bc square equal to 5, right? A plus b equal to 2. Just matching these, right? A plus b 2, a plus b c square will be equal to 5 and so on. Just keep matching them, you will end up with the same set as me. So 2bc minus 2a, 2bc minus 2a, this one will be equal to minus 6, right? And then we have 4a equal to 4, right? Yeah, wait, small mistake, this will be 4 here, right? Because these are twice. Okay, so 2xy minus 2xy, that was correct, plus 4x minus 4y. So that would give me 4 here and 4 there. So that will give me 4 here and 4ax there, right? So I'll get minus, no, plus 4a equal to 4, 4a equal to 4, and then minus 4a equal to minus 4, and 4a plus d equal to 0. So these are the set of equations that we get, right? These two equations are basically the same, so we don't get anything from here apart from a equal to 1. Now if we have a equal to 1, we have d equal to 1 minus 4, right? We have d equal to minus 4. So we have obtained these two. Now what remains? From here I can get b equal to 1, right? A plus b equal to 2, that means I'll get b equals to 1. A is obtained, d is minus 4, b is 1, and I'll need 1 for c, right? So here you can put it in either. So this will be 1 plus 1 into c square. So 1 plus c square will be equal to 5. That would give me c equal to 2, right? Because I'll take the positive square root, and you can verify this by, okay, I'll take both of the roots, plus minus 2. So I'll put it in here and check. This is basically bc minus a equal to minus 3. So I'll have 1 into c minus 1 equal to minus 3. So that would give me c equal to minus 2. Yeah, so the positive one will be not taken. Therefore c equal to minus 2 plus 2 doesn't, is inadmissible. Alright, this is inadmissible because it does not work with this one. So once we put the values back, what would we get? If we put the values back, this will simplify this to the first equation. Alright, because we started with this entire equation and then we got the coefficients back. So if we put back the coefficients, we will surely get this equation, right? Alright, once that is done, now we have to solve the second part, obviously the main part of this problem. And for the main part of this problem, we are going to do it in the same way that we looked at the first part. Alright, so for the second equation, this is equation B, right? So for equation B, I will set 6x square plus 3y square minus 8xy plus 8x minus 8y equal to that same thing, which is a into x minus y plus 2 whole square plus b into cx plus y whole square plus d. Alright, now once we do that, what would we get? We would get the same coefficients, right? Because we are doing the same process, the same simplification process. So there is no way that we are getting any different coefficients on the right hand side, right? All of our differences will come from the matchings of the left hand side coefficient and the right hand side coefficient, which will give us different solutions. Alright, but these a plus bc square and a plus b and 2bc minus 2a and minus 4ay, all of these will be the same. So this will also turn out to be, at RHS we will have a plus bc, because nothing is different, right? A plus bc square x square plus a plus b into y square plus 2bc minus 2a xy plus 4ax minus 4ay plus 4a plus d. Alright, that will be the same thing. Now comparing with LHS, what would we have? We would have a plus bc square, here the values will change, equal to 6, a plus b equal to 3, we have 2bc minus 2a will be equal to minus 8, 4a will be equal to minus 8, right? No, just 8. Minus 4a will be equal to minus 8, and 4a plus d is equal to 0 again. So again we do that solution. So from here we get a equal to 2. Just as in the previous case, these two will give you the same consistent solution. From here you get d equal to minus 8. Alright, because 4 into 2 8, d minus 8. Okay, now we go back. This gives us b equal to 1. Right, we are not solving this equation because here we would get a square solution and we would have to check it again. So directly putting it here, I'll get twice b, which means 2c minus 2 into 4 is minus 8. So this will be minus 4, which will give me c equal to minus 2. Alright, so that is a set that we obtain. Now once we have obtained both of these sets, rewriting the equations, we can write this first one in this format, right? We have obtained the a, b, c and d from the first one. So I could write a equal to 1, that means x minus y plus 2 whole square, plus b was 1 here, that would give me cx plus y in the brackets. C was minus 2 here, so minus 2x plus y whole square again, plus d was minus 4 equal to, we had this one equals to 9, right? That will be our first equation. Alright, we just set it to all of the variables that we found, alright, that we had put. In the next one we would get a was 2, right? So twice into x minus y plus 2 whole square, plus b here was again 1, so c is again minus 2, minus 2x plus y whole square minus 8 here. That would give us equal to 14. Right, so these are the two equations that we have. Now I can just make these to the right hand side, right? So I'll get 13 and 22 equal to 13 and 22. Now these equations are in the form of simultaneous equations, right? I can set this one as 1, this one as 2, and then I can multiply the first one by 2 and subtract, right? So I can do twice into 1 minus 2, that would give me twice into, so this will be twice, this will be just once, so I'll get minus 2x plus y whole square equal to 4, right? This is the first thing that I'll get, which means I'll get minus 2x plus y equal to plus minus 2, which means here I have minus 2x plus y equal to 2 and minus 2x minus y equals to minus 2. This is what happens when you get twice into 1. So we are eliminating this portion, eliminating this. We can also eliminate the other section, so that will be just subtracting, right? I can just do 2 minus 1, so that would give us x minus, sorry, so that would give us x minus y plus 2 whole square equal to 9, right? So this would give me x minus y plus 2 equal to plus minus 3, which means I have x minus y equal to, if I take the positive part and then subtract the 2, 1, and if I have the negative part, x minus y equal to minus 3 minus 5. So here are 4 equations, 4 simultaneous equations, 4 sets. Now I will have to solve them pairwise. Okay, so I'll solve so I'll have to solve minus 2x plus y equal to 2 and minus 2x plus y equal to 2, and I can go for x minus y equal to 1. Solving this, if I add them, I'll get minus x equal to 3, that means x equal to minus 3, and if I have x equal to minus 3, then y will be minus 4, right? Then I'll have this second equation where I have minus, this is the same one, minus 2x plus y equal to 2, and I'll have x minus y equal to minus 5. Alright, so from this equation I'll have, again I'll add them, I'll get minus x equal to minus 3. So I'll get x equal to 3 here. If I get x equal to 3, 3 minus y equal to minus 5, so y will be equal to 8. Right? Now the first equation, this equation has been solved with these two. Next we need to solve this equation with these two. Alright, so go for it. The third one will be minus 2x minus y equals to minus 2 and x minus y equal to 1. So this time you subtract it and you will get minus 3x equal to minus 3. So that would give you minus 3x equal to minus 3, x equal to 1. Right? When you have x equal to 1, well, y should be equal to 0. And then the last one, I have minus 2x minus y equals to minus 2 and x minus y equals to minus 5. Again subtract it, I'll get minus 3x equal to plus 3. So x equal to minus 1. If I have x equal to minus 1, then y will be equal to 4. Alright? Oh, did I make a mistake here? If I subtract it, I'll get, just let me check. This is x minus y equal to minus 5, fine. And then I have minus 2x plus y equal to minus 2. Just a moment. Okay, here it will be plus only, right? Because we are changing only the sign on the right hand side. So that was the mistake. So here it will be plus, here it will be minus. Alright, so even in this case I have 2y equal to 0. So this solution holds anyway. We made a small mistake, but the solution turned out to be correct. So if 2x plus y, let us check the fourth solution again. If we subtract this one, okay, we don't need to subtract, we can just add it. We'll get minus x equal to minus 7, right? So x will be equal to 7. X will be equal to 7. Here the coefficient did not matter because x turned out to be 1. If x turned out to be 1, then y will be 0 irrespective of its coefficients. Alright, so here x is 7 and for y it will be minus 12, right? No, it will just be 12 because if I subtract 12 from 7, I'll end up with minus 5. Okay, so here are the 4 solutions. Now if you want, you can put these values and check. Otherwise you can be quite sure, if you have not made any calculation errors, that these will be the correct answers. Okay, so the solution points, the solution pairs are, you can just list the pairs one by one and that will give you your answer. Just give me a minute, I'll list them. You have minus 3 comma minus 4, 3 comma 8, 1 comma 0 and 7 comma 12. Now before I end this problem, I would just like to talk to you about why do you have 4 different solutions. Alright, first of all, we have 4 different solutions because we have quadratic simultaneous equations, right? So each quadratic only has 2 solutions or less. Okay, so the maximum number of solutions of a quadratic is 2, and here we have 2 sets of those, so that is why 4 solutions. Okay, and also if you look into this equation given, this is the equation of an ellipse. Alright, so basically we are looking into how two ellipses can intersect. Now you know from geometry that two ellipses will intersect in at most four different points, right? They can intersect in less, but four is what is expected. So if this is an ellipse and let's say this is another ellipse, then there are four intersection points, right? One, two, three, and four. Okay, this is not the exact diagram for this particular problem. I'm stating it beforehand, not to not scaled to current problem. This is just explaining you that when two ellipses intersect, they can intersect in at most 4 points. I say at most because it can happen in lesser points also. So that is why you are geometrically getting four different solutions. Algebraically, you know, each quadratic can have maximum of two solutions by the fundamental theorem of algebra. So there are two quadratics, therefore you get four solutions. Alright, you may or may not always get all the four solutions, and that is why after getting these four pairs of solutions, if you want, you can check and verify. Alright, if I start checking and verifying, it will take a long time, but I can assure you that when I've done the problems, I've checked that these are verifiable. Alright, so I hope you understood how this question is done. It's a very nice problem, although it's quite easy, and there is no scope of even giving some hints to what is asked in the question, because everything is laid out quite clearly. You just have to follow the instruction for the first one, follow the instruction for the second one. Okay, simplify them into common terms and then subtract. Alright, so I'll end this video here. Let us know if you have any questions relating to this particular problem and mention it in the comment section. Our team will look into it. Okay, bye everyone, take care.